Again, we're given a graph that we don't know the equation of. Here's the graph of g of x. Sketch the graph of y equals negative g of x. So a couple of things. When I see this, it should trigger in me all the different ways I can say the same thing. That negative is outside of the function. So it should tell me right away that I'm going to multiply my y values by -1. Then I imagine if I took a point and I changed the y value to a -1, it would go down here. Can you imagine that? If you had a point 5, 5, you would now have 5, -5. And so it would reflect over the x-axis. So I know that my y value is getting multiplied by -1. If I visualize that, that reflects it down over the x-axis. That means we have a vertical reflection. Now that I know that, I can take some key points on my original graph. I have, textbook does this sometimes. Okay? I'm going to make a mistake, and most of you won't see the mistake. Are you ready? Okay? I mean, you're going to be more looking out for it, but I could have pulled this mistake so easily on you guys, you wouldn't have seen it at all. I'm going to just label these points 3, 1, and 1, 3. Can you see what I did? Yeah, now that I told you I was going to make a mistake, some of you can see it. Can you see yourself labeling this point as 3, 1? Or would you not do that? See, how tempting is it to label that point as 3, 1? Because it's just 1 up, right? But look at the scale that we're given. They're going up by 2s. So this point is actually 3, 2, and this one is 1, 6. Just because the scale is different. So you have to be careful with the scale, because sometimes they go by 1, sometimes they go by 2s. So be careful with that. Now, what's going to happen to 3, 2? It's going to become reflected over the x. The y values get multiplied by -1, 3, -2. And 1, 6, 1, -6. Can you imagine it reflected over? Can you see it look like this in the end? Now, those 2 points where it changed, sort of like a little maximum, a little minimum, those were key points to graph. They helped us figure out where points on our other graph are. There's one other important point on here that I did correct this first time, but I'm going to do it wrong the second time. So I'm going to just erase what I did. Arrowheads are gone, graph is gone. And I'm going to draw it again, just like I did before, but this time I'm going to make a mistake. Okay? Again, it's attention to detail. What was the tiny mistake, or what do you think the other key point they might be looking for on the exam? Actually, I think I might have even made the mistake the first time. So maybe I've made the mistake now twice. And we have to figure out what other key point might they be looking for when we reflect it. Yes, okay. Well, I mean, this is an x cubed, so we don't really have a vertex per se, but I have this point and this point matched up perfectly. The y-intercept, So this time my y-intercept here is down at -4. And here my y-intercept is at 2. So that could be something I could do better. Yes. I'm going to erase a little bit more. So there was a couple of points that could be better. My y-intercept here is at 2. And so it should be at -2. That could be a point that they're looking for. But one point in particular that they really, really like is where the graphs cross. So the question is, when I draw this one, it's going to cross the red graph, and it's going to cross the red graph right at the x-intercept. I don't know what that point is exactly, but I know it has to cross there. Why does it have to cross there? Does it make sense if I flip it over the y, that whatever your y-intercept, your x-intercept point is not going to change? So it could be another key point that they're looking for, that that point stays the same. And there might be a question sometime is, here's your red graph. If you flip it over the x-axis, where do the graphs intersect? So you have to be aware that they would intersect at that x-intercept. State the domain and range of each function. So sometimes I'm not very good at modeling when I'm teaching, but I don't know if you noticed I've already read the question 3 times. I read it in my head. I finish a part, and then I reread the whole question. Oh, I haven't done the domain and range yet. So again, in math, we often have to reread a question many times. For this one, for our red graph, the domain is everything. The range is everything. In our blue graph, the domain is still everything. The range is still everything. Questions for practice on this one are 4, 5, 6, 10, and 11.